Hello, this is Saqib. In the last few videos, I gave a brief overview of the Interpretable AI nodes available in Knime 4.0 release. In this video, we'll take a look at the Partial Dependency Plot node available in Knime as part of the Interpretable AI nodes. To recap, a partial dependence plot shows how a single continuous predictor variable impacts the output of a model when holding all other predictors constant. So essentially, we take a look at a single predictor variable and observe how the model behaves when we vary the value of that predictor variable in a predefined domain. This is achieved by generating samples by varying the value of the given predictor. Knime has nodes that can generate these samples and then help visualize that sample data. Well, I'm using the heart failure data set from the UCI machine learning repository. This data set consists of various clinical features captured during the heart examination of patients. The response variable is whether that event occurred before the patient's next checkup. So if we take a look at the predictor variables and the response, this is our response variable, that event, and we have several predictor variables including the age, anemia, ejection fraction, which is essentially the rate of the flow from the heart. It's given as a fraction, and whether the person smokes or not, and several the platelet counts and several other features. So we'll build a model using this data set, but what we want to take a look at is how any of the continuous variables impact the final output of the model. Before we get into using the Interpretable AI Nodes Inline, let's take a look at the output of the partial dependence plot in Knime. So let's take a look at that. Let's click OK. And once I open up the partial dependence plot, it brings up a Chrome browser window with several plots. And to move around within the plots, we have you can click on this menu, and it essentially lists all the features that are part of your model. So these are all the continuous variables that are part of your model. So in this case, we have the age, the creatinine, ejection fraction, platelet count, serum, creatinine, and serum sodium. As I mentioned earlier on, the partial dependence plot shows how a model behaves when you vary a single predictor variable, a single continuous predictor variable in a predefined domain, while holding all the other predictors constant. So in this case, if we take a look at the plot for the age, we see that as the age increases, let me close this out. As the age increases, the probability of that event equals to true goes up. So this is our class probability for that event equals to true. And as you can see, as the age goes up, so we are varying the age in this given model, and we see that as the age goes up, the probability of that event, the class probability of that event equals to true goes up. Now let's take a look at another continuous variable in this model. So in this case, let's take our ejection fraction. So this is the rate of the flow as it comes out of your heart. So if we take a look at this variable, and what's evident from this plot is that as the lower the ejection fraction, the higher the class probability for the death events equals to true. So another, so we can say that in this particular model, the way that it was built, if we have a lower ejection fraction, the model will predict that event to be true based on how we set our cutoff. But the probability of the class probability of that event equals to true goes up when the ejection fraction is lower. Similarly, if we go back to the age, what this is telling us is the way that this model works is that if the age goes up, the class probability of that event equal to true goes up as well. How to use these interpretable AI nodes in Knime. To start off, first you have to build your models. So you start off with your data, then you decide on which model to use, and then you use the learner node and the predictor node as usual. But in this case, to use the interpretable AI nodes in Knime, you have to use this partial dependence preprocessing meta node. This meta node is available for Knime from Knime website, and you can download it and use it as it is. What this node does is generates a sample of data by varying the predictor variable in a predefined domain that your partial dependence plot node uses to visualize the data. So the two nodes that you have to use is the preprocessing nodes and the partial dependence plot node. Now let's take a look at the configuration for the preprocessing nodes. It's pretty straightforward. All you have to do is select all the predictor variables, the continuous predictor variables in your model that you want to plot, and the number of samples. In this case, I left it off at 100, which is the default value. And now let's take a look at the partial dependence plot configuration. So in this case, the features that we sampled in our previous preprocessing node, we have to select those. In this case, we use the age, the ejection fraction, platelet count, serum, and the creatinine predictor variables. And again, the prediction columns, in our case, this is the class probability for that predictor variable. Sorry, the class probability of the prediction. So now, so that's the configuration for that, and I think that's pretty much it for the configuration. One thing to note is that to add the class probabilities to your Knime workflow in your predictor node, you actually have to specify that by going into the configuration, you have to specify that append the individual class probabilities. So once you do that, your class probabilities will be available in the partial dependence plot node right here. So once you have set that up, pretty much you run your flow, and then once you actually take a look at the output of the partial dependence plot, it brings it in a Chrome browser, and you can explore all your continuous variables by going into this menu, and it will plot. It will give you a partial dependence plot for each of the continuous variable in your model. So hopefully this was useful, and this just gives you an overview of the partial dependence plot, where it comes from, and how to use that in Knime. Hopefully you liked the video. Thank you. Bye-bye.